In this video, I'm going to show you how to use the quadratic formula to solve equations. Now, before we start any actual examples, I need to remind you of a couple things. The first thing I want to remind you about is something called standard form. So a quadratic equation can be written in standard form if it is in the form ax squared plus bx plus c is equal to 0. All right, and the reason why I want to remind you about this is because if we're going to use quadratic formula uses the a, b, and c values from standard form. So what does quadratic formula look like? Wow, I can't spell. Quadratic formula. It's even worse because the word's right below it. Okay. I think I can fit that in there. So I'll just zoom and make it a little bigger. All right, quadratic formula. X is equal to the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. So again, why I mentioned the whole idea of the standard form is the value that's in front of x squared, this a value, is going to fit into your quadratic formula right after the 4 here, so 4ac, and then in the denominator for 2a. Okay, so that's the first part. Then you've got the b value, which is the coefficient to x. Sometimes you'll hear people refer to this as the middle term, all right, but it's that coefficient to x. So b here, I'm going to do the opposite of b, and then I need to do b squared. Okay, so both of those values are the same from this b value. And then this constant at the end of the standard form is going to be the last value here in that 4ac. So you're going to take 4 times your a value times your c value, and that will be then how you can use those numbers in the quadratic formula to find your answers. Okay? So let's take a look at the first example. Okay, problem number 1. I have the problem 6x squared plus 5x minus 22 is equal to 0. So the first thing I want to look for, is it in standard form? Yes, it is. So now that I know it's in standard form, this is my method, I am going to make a little list for myself to tell myself what A, B, and C are. Now, if you don't need this, you don't need to use it, okay? So I'm going to go across. The coefficient of x squared is 6. The coefficient of x is 5. And the constant in this problem is negative 22. And yes, the negative matters. All right, so make sure you don't lose it. Now that I know those 3 values, it becomes, it's going to look big, but it becomes a simple substitution problem. So x is equal to, and I'm just using this formula right up here, okay, the opposite of b. Well, b is 5, so the opposite of that would be negative 5, plus or minus the square root of b squared. So I'm going to put 5 squared, please use parentheses, minus 4 times the a value of 6 times the c value of negative 22. I never make that square root radical long enough, all over 2 times my a value. Okay, so take a second here, just take a look, make sure everything's in the right place. Opposite of b, b squared, 4ac, all right, yeah, okay, so everything's in the right place. Now, this is a place where I'm going to make my calculator do as much work as I can, but I need to be careful that I don't try and make it do too much. So to that end, I am going to put everything under the square root of my calculator, but not the actual square root itself. Okay? So I'm going to slide up so I can have a little bit more space here. So x is equal to negative 5 plus or minus the square root of. So now in my calculator, I'm going to do 5 squared minus 4 times 6 times negative 22. And I get an answer of 553. So 553 all over, and now in the denominator, I'm going to take 2 times 6, and that gets me 12. Now, depending on what the expectation is for the problem, for what you want to do, you may need to simplify this square root. For my purposes, all I'm going to be looking to do is see, is the square root a perfect square? If it is, then I will simplify further. If it is not a perfect square, I'm just going to let it be the square root of, in this case, 553. So how do I know? Now, I don't know what necessarily, my square roots after 100 or 400 are, depending on how much you know about them. So throw this in your calculator. Take the square root of 553, and if you get a decimal answer, immediately you know that that's not a perfect square. So at this point, for this particular problem, you are done. Okay? It's a wacky answer, but mathematically, this is the exact answer. Technically, there's two, because you have both the positive here and the negative here. That's two different answers. Okay? So if you don't have to deal with the square root, don't deal with it. Just let it be square root of 553. If the directions say to use decimals where appropriate. Okay? So I'm going to move on to example number 2. And immediately my brain notices this equation is not written in standard form. Okay? So remember, standard form, ax squared plus bx plus c is equal to 0, and no, we're not there. So I want to make this turn into standard form. And you can do one of two things. You can either move this term on the left, the negative r squared, and move it over to the right, or you can take these two terms on the right and move them to the left. It really will not matter. So for me, I'm just going to move the single term. So I'm going to go ahead and say plus r squared. So plus r squared, right? Add r squared to both sides. So 0 is equal to, I want my expression in standard form, descending order. So r squared plus 6r minus 72. Okay, make sure it's in standard form. It is. Now that it's in standard form, I'm going to take a second, identify a, b, and c. So in this particular question, what is the coefficient in front of r squared? Well, there's no number written there, so we assume it's a 1. Okay, that's just a mathematician way to, we're too lazy normally as mathematicians to put the 1 there, but it is there. And coefficient in front of r is going to be 6. And the constant in this case is going to be negative 72. Okay. So I've got all these numbers now for a, b, and c. Now, one thing that's a little goofy about quadratic formula, it's always written from the perspective of x, as in x squared is equal to the opposite of b, so forth, so on. However, if your equation has a different variable, in this case it's r, you want to recognize that the variable in this case is r equals, okay, but the rest of the quadratic formula will stay the same. So the opposite of b, negative 6, plus or minus the square root of 6 squared minus 4 times my a value, which is 1, times my c value of negative 72, all over 2 times 1. All right. So what goes in the calculator? For me, I am going to put this entire expression in my calculator without the square root sign. Okay. So negative 6 plus or minus the square root into my calculator. That goes. So 6 squared minus 4 times 1 times negative 72 is 324. All over 2 times 1 is 2. All right, so 324. I don't know if it's a perfect square or not, so I'm going to take the square root of 324. Ooh, my calculator just told me that answer is 18. So this is going to simplify now. I'm going to take it further. So negative 6 plus or minus 18 over 2. No more radical anymore. And because there's no more radical, I can go further with this. All right, so lots of different ways to deal with it. I tend to visually separate it. So I've got negative 6 plus 18 over 2. And then separately, I have negative 6 minus 18 over 2. So negative 6 plus 18 is 12 divided by 2 is 6. Negative 6 minus 18 is negative 24. Negative 24 divided by 2 is negative 12. So after all this work, okay, my final answers, plural, 2 answers, r is equal to 6 and r is equal to negative 12. So I'm going to zoom out here just a touch so you can see all the parts of it. So first thing we did, I turned the equation, the original given equation, into standard form. From standard form, I identified my a, b, and c values. Once I had those, I substituted into the quadratic formula. I simplified the expression underneath the square root. Because this value is considered a perfect square, I was able to take the square root, split it up into 2 miniature little expressions here, simplified them both, and I got my values for r. Okay, so you've now seen what happens if you get a perfect square and what happens if you don't, so you kind of understand how to work with those. Okay, all right, I am going to take a look at problem number 3 here, example number 3. So first thing to look for, is it in standard form? And it kind of looks like it is. Right, we've got an n squared term, 6n squared plus 10n minus 86. So left side looks good. But when we get over to the right side, standard form has to be equal to 0, and this is not. So I need to make it be equal to 0. How am I going to do that? I am going to add 2 to both sides. So 6n squared plus 10n minus 84 is equal to 0. In this particular problem, you can do one of two things here. You could absolutely say A is equal, B is equal, C is equal. One thing I noticed in this problem, you don't have to do this, but it might help a little bit to keep the number smaller. Sorry about that. My little computer here is going insane. I recognize right away that 6, 10, and 84 are all divisible by 2. So to keep the numbers a little smaller, I'm actually going to take a second and divide every part of this equation by 2. So I would get 3n squared plus 5n minus, I believe that's 42, is equal to 0. So that just, again, it makes the numbers a little smaller. It's not going to change the answer per se, but it just makes working with quadratic formula a little easier. So I've got A is equal to 3, B is equal to 5, and C is equal to a lovely little negative 42. Using those three values, again, this particular equation is written in terms of the variable n. So I'm going to say n is equal to the opposite of b, plus or minus the square root of, that is so not long enough. Let's try that again. Okay, so b squared minus 4ac all over 2a. If you ever do need to memorize the quadratic formula for any reason, there are some wonderful videos that have people who will sing the tune of sing the quadratic equation to the tune of Pop Goes the Weasel. I am absolutely not going to sing for you, so and you should be thankful for that. All right. So in the meantime, what I did is I put this expression, the 5 squared minus 4 times 3 times negative 42 in my calculator, and I got 529 all over 2 times 3 is 6. 529, I don't know if it's perfect square or not. It is, and the way I know that, very honestly, is I have a calculator sitting next to me, and I put it in my calculator. So the square root of 529 is 23 over 6, right? Because that's the denominator of 6. We don't want to lose it. So depending on how you want to do this, again, for me visually, I just split this into two separate fractions so that I can simplify each one separately and make sure I end up with all of the answers I'm supposed to have. So that was the positive up on top. I'm going to put the negative on the bottom. So 23 over 6. All right. Negative 5 plus 23 divided by 6 is 3. Let's see, negative 5 minus 23. Now that's going to turn into a fraction, or technically it turns into a decimal, whichever way you want to phrase it. I tend to leave my answers as fractions and just reduce them. So n is equal to 3 or negative 14 over 3. Either one of those is appropriate. So let's show you the whole problem from start to finish. Okay. Up at the top here, we had to get the problem into standard form, which means we set it equal to 0. This next step was a little optional. I shouldn't say a little. It is totally optional. You did not have to divide by 2. Dividing by 2 in this case, it won't change the outcome. It just changes the values here. It will turn into smaller numbers. So I did do that division. Identified A, B, and C. From those identifiers, I used them to fill in the equation. I simplified what's under the radical, tried to take the square root. It did work. Split it into two fractions, simplified those fractions, and got my two answers. Okay, so that's example number 3, and let's take a look at the last one here, example number 4, which already looks kind of promising here. As that's going to be a lot of fun. All right. This is so not in standard form, not even close. I noticed that I have 5v squared here and a negative 3. I'm going to make sure this v squared is positive. So I'm going to take everything from the right side here and move it to the left. And I'm going to do this in one step. So that means I am going to add 3v squared. All right. I am going to subtract 3. And I'm going to add 8v to both sides. So the right side, those pieces cancel, those cancel, and those cancel. So this whole right side is 0. Let's see what we've got here. 8v squared minus 5v minus 17. That's in standard form. All right. So once it's in standard form, I'm just going to take a second here to keep track of my A, B, and C values. I've said it once, I'll say it again. You don't have to. All right, this is just my method of making sure that I don't screw something up with a sign, and it also just focuses me on my list. So variable change here, V is equal to the opposite of B. Now, if B is negative already, the opposite of a negative is a positive 5 in this case. So 5 plus or minus the square root. B is negative 5. We're going to square that. Minus 4 times A times C all over 2 times your A value. All right. Now, this has not been an issue so far, but please be careful with this term right here. It is in parentheses for a reason, okay? The reason it's in parentheses is because you need to make sure that you are taking negative 5 times another negative 5, all right? If you don't, if you leave those parentheses off, all right, and you put negative 5 squared in your calculator is going to lie to you. Your calculator is going to take 5 and square it, and then it is going to apply this negative sign. It's following the order of operations, but that's not what you mean for it to do. So the way you prevent that from being an issue, the way you prevent your calculator from lying to you, is make sure that you put that negative 5 in parentheses. Then square that quantity. All right, so be careful with that when you are using a calculator. It is only going to be as good as the information that you give it. It can't assume anything. Okay, so negative 5 squared, in parentheses there, right? Minus 4 times a times your c value is 569. 516, wow, I can't write a 9. 9 all over 2 times a to 16. All right, so I am going to take my calculator. I'm going to test and see if 569 is a perfect square. When I take the square root, I got 23 point, and as soon as I see the decimals, I stop paying attention to it because it's not a perfect square. And so I am perfectly content to put a box around it and call that problem done. So the difficulty with this particular example was to turn this mess of an equation that we started with into standard form. So get one side equal to 0. It doesn't matter which side, but get one of them equal to 0. Then once you've got standard form, identify a, b, and c, substitute it into the quadratic formula, simplify what's under the radical and the denominator, and then see if this numerator here has a perfect square in it. Okay? So I hope this video has helped give you a lot of information on how to use the quadratic formula to solve quadratic equations.